Hey, triggers. Let's get ready for that Unit 2 test. Which function is graphed below? Well, all my options are cosine options. And I'm going to consult my trusty unit circle to remind me what the graph of cosine is supposed to look like. When theta is 0, cosine, which is the x value on our unit circle, when theta is 0, cosine is 1. So that means that cosine of 0 is 1. So when x is 0 on this graph, cosine is 1. When theta is pi over 2, cosine is 0. So at pi over 2, graph of cosine will go up 0. When theta is pi, cosine is negative 1. So pi, negative 1. At 3 pi over 2, cosine is 0 again. And then at 2 pi, cosine is 1 again. Back up here at 1. So cosine looks something like this. So cosine is our blue and mystery curve is in red here. First thing I notice is that the red curve is reflected across the x-axis, which means we need to have a negative in front of the cosine. So that tells me it's not going to be A and it's not going to be C. It's either negative 2 cosine x or it's negative cosine of 2x. Now when you have a 2 out in the front, that changes the amplitude, and when you have a 2 inside the cosine argument, so near the x, that changes the period. While we have the same period here, the period is still 2 pi. So our amplitude is what's changed, and our amplitude, instead of being 1 away from the x-axis, is double that. It's 2 away. So the answer is B, negative 2 cosine x. Number 2, cosine of 2 pi over 3. Once again, my trusty unit circle is going to save the day for me. Alright, so when theta is 2 pi over 3, so let's see, here's pi over 3, here's 2 pi over 3. What is cosine of theta? It is negative 1/2. Bing! Easy money. Sine of negative pi over 4. Once again, my best friend. Negative pi over 4, let's see. 2 pi is right here. So negative pi over 4 would be just backwards down to here. So why did I talk about 2 pi? Because 2 pi is the same as 8 pi over 4, and that tells me that negative pi over 4 is going to be the same angle as 7 pi over 4, because there's only one more pi over 4 to get back to the beginning. So if we go backwards a pi over 4, we're at 7 pi over 4. And what is the sine of 7 pi over 4? The same as negative pi over 4? Why, it's negative radical 2 over 2. Ooh, negative cotangent of 2 pi over 3. Let's see, negative cotangent. Well, cotangent is the reciprocal of tangent, and tangent is sine over cosine. So cotangent is going to be cosine over sine. So cosine of 2 pi over 3 divided by sine of 2 pi over 3. So let's find 2 pi over 3 right here. Cosine is negative 1/2. So negative 1/2, and then sine is radical 3 over 2. So remember, when you divide by a fraction, it's the same as multiplying by the reciprocal. So negative, and here's a good one, negative times negative is positive. So positive 1/2 times, I'm just going to, instead of dividing by radical 3 over 2, I'm going to multiply by 2 over radical 3. My 2's cancel, and I got 1 over radical 3. But I need to rationalize my denominator, so I'm going to multiply top and bottom by square root of 3, because this fraction just equals 1, so I'm allowed to do it. So what do I get? 1 times radical 3 is radical 3. Square root of 3 times square root of 3 is square root of 9, which is 3. So the answer should be C. Which function is graphed below? Is it sine x, or is it cosecant x, or is it negative cosecant x, or is it negative sine x? Well, most of us should know that sine looks like this, not like a bunch of different alternating U shapes. But we need to figure out if this is cosecant or negative cosecant. And what is cosecant? Cosecant is 1 over sine of x. So we can use our information from the unit circle about sine of x to tell us what cosecant of x is going to be doing. So let's just think about, let's just graph cosecant of x and see if it matches. How about when x is 0? When x is 0, sine is 0, and 1 over 0 is undefined. So it makes sense that we would have an asymptote here. Where else is sine 0? Sine is also 0 at pi. So when x is pi, we're also going to be undefined, so we're going to have an asymptote there. Oh, look again, it's also 0 at 2 pi, so we're going to have an asymptote there. It's starting to look like it might be cosecant. Well, let's check pi over 2. What is sine of pi over 2? Here's pi over 2. The sine is 1. So cosecant is 1 over 1, which is 1. So it looks like this is the graph of cosecant in red here, and the graph of negative cosecant would look just like the mirror image of that. So our answer is A, cosecant x. Use the function y equals secant 3 theta to find the value of y when theta is pi over 9. Well, y equals secant of 3 theta. Theta is pi over 9, so y equals secant of 3 times pi over 9. I can reduce this a little bit. 3 pi over 9 is pi over 3, so y equals secant of pi over 3, and secant is 1 over cosine. So this is 1 over cosine of pi thirds. Now, I'm going to reference my trusty unit circle and look for cosine of pi over 3. Cosine of pi over 3 is 1/2. So this is 1 over 1/2. Dividing by a fraction is the same as multiplying by the reciprocal, so that's the same as 1 times 2 over 1, which is 2. So the answer there is D. Now we're getting into what happens to a parent function when we start throwing extra numbers in here. So let's look at our sinusoidal, or just basic sine. Y equals a times sine of b times x plus c plus d. And here we got to remember that a is the amplitude, b is related to the period in this way. The period is 2 pi divided by b. And then c and d are translations, just shifts. So phase shift, we would go left c units, and we would go up d units. Okay, so that's just kind of like a big review for pretty much the rest of the test. So if here b is 3, so our period, I can't spell period today, is 2 pi over 3. So we're dividing by 3, which means our period is going to get 3 times shorter. Alright, so the solid graph is y equals cosine x. The dashed graph is a horizontal translation. What could be the function with the dashed graph? Well, a horizontal translation means we're just moving sideways. So we're either going to the right pi units or we're going to the left pi units. Either way, that would have to be, if this was cosine, it would be cosine of x plus or minus pi. Or if we're thinking about it being a sine, and a sine wave would start here, then it's only going pi over 2 to the right, or it would be pi over 2 to the right, or it would actually have to be 3 pi over 2 to the left to get back to where that guy starts over there. So that would be sine of x minus pi over 2. So what do we got up here? We got cosine of x plus pi. So that would work. Cosine of x plus pi would move us to the left pi units. So it would be a translation left of pi over 2. So bada boom, bada bing. Cosine of x plus pi is a translation left. Ooh, what's the period? Well, the period is determined by b, which is this guy right here, and the period is 2 pi over b. Well, dividing by pi over 2 is the same as multiplying by the reciprocal, 2 over pi. So here the pi's will cancel. Pi divided by pi is 1, 2 times 2 is 4, and the answer is D. So the solid here is y equals cosine x. The dashed is a vertical translation. So here's cosine, and we're going down 1 unit. So that is cosine of x minus 1. What is the amplitude of the sinusoidal given by this equation? Well, the amplitude is the number multiplied by cosine, or sine, whatever it is. So the amplitude is 2. What is the phase shift? Well, the phase shift is this part is the horizontal shift. And so we're going 3 units to the right, because when you're inside here with the x, it goes the opposite direction you might think. Negative is to the right. Okay, we're all done, and it happened in under 15 minutes, so congratulations to everyone.